I'm on. Okay, great. Thank you. Good afternoon. My name is Sean Smith, and I work for Oracle, and I work on the EclipseLink Project, which is the JPA2 reference implementation, and I'm working on JPA 2.1. And today I'm going to talk to you about sort of the evolution of Java persistence. So I've been working in Java, well, in persistence since '97. I started in Smalltalk with TopLink, which became TopLink for Java, which has been open sourced and became EclipseLink, and I've been involved both as a community member, sort of a consultant, and then eventually working with Oracle. And so things in the world of Java persistence are moving. And so you may have a very narrow view of what Java persistence is, but maybe I'll expand your horizons a little bit. So it's an Oracle disclaimer, don't worry. Don't buy anything based on this talk. Okay, so Java persistence. So most of you will think of Java persistence as relational database persistence. And that's what you see on the left-hand side of that slide, right? So Java classes going to relational tables, right? And so that's JPA, right? Java Persistence API covers persisting into relational databases. But for us, persistence is transforming in-memory Java objects into some sort of durable format. And so we went from relational, actually we went to mainframes. We had people on mainframe customers, wanted to get access to their data on mainframe. So we built this mainframe interface, and that sort of evolved into actually XML support. And so now today, of course, JAXB is the standard for XML to Java binding or transformation. And EclipseLink supports both of those standards. We also built something called DBWS, which builds on both of those technologies. So for building web services, JAX-WS web services on top of relational databases. And I won't talk about that today, but it's sort of a combination of the two technologies. I apologize for my voice. I woke up this morning and I thought I wasn't going to be able to talk at all because I was like, completely clogged up. So my voice is getting deeper, but I hope you can still understand me. So like I said, today we implement JPA 2.0. We implement JAXB 2.2. We also implement SDO 2.1.1. And I'm betting I'm the only person at this conference who's going to talk, who would ever mention service data objects. I think that technology has passed its time. But it turns out that we actually implement it, and we are the reference implementation for that too. So EclipseLink is the reference implementation for both JPA 2 and SDO 2.1.1, which are quite different technologies yet built in the same core. And it turns out SDO is used quite a lot internally at Oracle, and I think also SAP uses it internally for some of their products too. So recently there's been some work we've been doing in EclipseLink. And I'll talk about these things in this talk. JSON binding. JSON's very big. We happen to know a lot about XML binding, so maybe we can do something in that space. Dynamic JPA, the idea that you may want to get access to relational data, use Java, but not actually have Java classes written up front. Could happen. Tenant isolation or multi-tenancy. I spoke about that last year, so I'm not going to go into that. But that's a topic in itself, and really it's sort of we're a bit of ahead of the game in terms of multi-tenancy support in Java standard frameworks because, as we all know, the cloud and all that has moved to Java EE 8. So we were a bit ahead of the game, and so maybe it'll come back again. We'll talk about it next year. RESTful JPA. So if you've got JPA applications and you built in your on your application server or wherever, and maybe you want to get at that over REST, right? Why wouldn't you want remote access to your data? Certainly possible. And then, of course, there's NoSQL. NoSQL is big, right? I went to a conference recently in New York City, and I think 9 out of 10 vendors on the trade show floor were NoSQL database vendors of some sort. And so there's a big movement in the NoSQL space. And then sort of in the future, we're looking at JPA 2.1. That's something we're actually working on now. The specification's in progress. There's a number of public drafts available. I think there's one came out just last month. So we're working on that. JSON-B, there's no specification for how to bind Java to JSON currently. And there's a talk by my colleague on JSON-P, parsing. So JSON parsing, it's going in Java EE 7. So being able to parse JSON documents and get like a DOM structure out. JSON-B, where you would bind Java objects directly to JSON structures, there's no spec yet, but maybe. And then there's a question of whether there'll be a Java standard for NoSQL persistence. And currently there isn't one, but that's something else. So some of the things we're playing with here are going to feed into some of these possible futures. So I'm going to walk through some of those. So just for your benefit here, some background, EclipseLink implements these technologies, JPA. Moxie is our JAXB component. and DBWS, and they're all built on the same core engine. This is sort of how we sort of achieve a number of things we want to do efficiently. We build on one core engine. So we're transforming from Java, whether it's Java SE, EE, or OSGI. If you're interested in OSGI persistence, EclipseLink is a part of the Gemini JPA reference implementation for enterprise OSGI JPA. And regardless of what sort of Java environment you're in, we want to let you get whatever backend data or whatever sort of persistent data you want to get at. So we're trying to be the middleman here for a number of different technologies. And it's used in many places, and people ship it with them. So let's move on here. So JSON binding. So this is a big topic. The team lead on the EclipseLink project for XML, Moxie, is Blaise Dawn. And Blaise, if you know Blaise, he's a very prolific blogger. He's probably blogging now. I think he's asleep, but he could be blogging in his sleep, composing a blog, because he blogs a lot. And he's the one who first started talking about JSON binding. He said, we know how to do XML binding. There's a big need for JSON. You see people like Twitter abandoning XML web interfaces and going to going to JSON. What are we going to do in this space? And so we have something today that's been shipping for a while. The temporary step we're taking here before there's a JSON binding specification is to leverage our XML or our JAXB mapping expertise and infrastructure. So we're essentially using the JAXB mappings and the JAXB marshalling code we built to support JSON. And so we can transform Java objects into JSON and back and forth either way. Like I say, there's no standard, so we really had to, for now we're stuck with sort of XML binding annotations, which looks a bit odd, and I'll show you some code. It does work quite nicely and has some interesting properties. The nice thing about how you select between JSON and XML with EclipseLink is you set a media type on the marshaller. So you take a JAXB marshaller and said, I want JSON, application/JSON, and suddenly JSON starts being emitted or consumed from the marshaller or unmarshaller. So our goals were at the current time, again, lacking a standard, was to just reuse what we had. So let's just take JAXB and make it work for JSON with one set of mappings. Like I say, there's an advantage in that you can just switch back and forth between what you want by setting the media type. You have one set of annotations to configure. This doesn't add any more compile time dependencies to an application. It's just JAXB currently. And it's very easy to use with JAX-RS. So like I say, Blaise's blog, he has a lot of discussion over how to plug in the EclipseLink JSON support into, say, Jersey or other JAX-RS providers. So it really looks like this. You have XML annotations, JAXB annotations on your class, and you can either produce XML or equivalent JSON. The JSON on the lower right-hand side there has a root element, and that is optional, so we can turn it on and off. It doesn't make sense in many cases to have sort of foo as a root element. It really is just an object with ID and bar. And you see in the lower part how I can just select that. So I set the media type to be JSON, and I can control whether the application root shows or the JSON root shows or not. In this case, it's set to false. Yet in my example, I've shown it, so I apologize. And then we just marshal the objects out. It's as simple as that. So we've built this, and it's working quite nicely. But there are actually some challenges we had to get over before we could implement that. And that is, we're interested in building front-to-back solutions. So we have database in the back end. We have web clients in the front end. I'm using JPA to map to the database. I have JSON or XML binding to map from my domain objects onto something I can transmit down to the client. The problem is that JPA and JAXB were developed by separate expert groups who I believe don't talk to each other. So there's some impedance mismatches. They're lurking in there in JAXB and JPA. And the obvious thing is that in a database, you've got cyclical relationships, right? You've got relationships going all over the place. Whereas in XML, it's typically more hierarchical, so you go top down. You don't tend to have the cycles. And so if you're pulling data out of a database that has sort of cycles, and you try and call a marshaller on that, you'll get a Stack Overflow pretty quick. In fact, if you go get the JDK and use the Metro JAXB JAXB implementation that's in there, that's what's going to happen to you. Try it, and I'll show you it fail in a second. The other thing is composite keys, embedded keys. So the idea of identification in databases is more sophisticated than XML. XML has a much simpler scheme for identifying objects. And then there's this sort of subtle issue of bytecode weaving. This one's more of an implementation issue. All the major JPA providers use bytecode weaving of some sort, ASM, to either enhance classes, weave in code. We do that for change tracking and a number of other optimizations, or generate subclasses, whatever the case may be. There's a lot of magic going on behind the scenes. And if you take sort of this woven class that JPA provider has built, and you hand it to a JAXB implementation, it interrogates the object, uses reflection, finds a few things, and starts recursively marshalling. Well, there's a whole bunch of stuff on that object that may not be suitable to marshal. It could be things like key caches and change trackers and all kinds of objects that are attached to your object for JPA that the JAXB implementation doesn't know about and shouldn't know about. So we learned that pretty quick when started playing around with these two technologies together. And the upside of EclipseLink is we have people on both expert groups, JAXB and JPA, and we have reference implementation for one, and implementers of both. So we know both sides of the story, right, in this case. We know both technologies really well. We know what the specs are. So we were able to come up with solutions to let these two work together. So here's how we dealt with bidirectional relationships. This is a very typical JPA structure. So I have a project, has a collection of employees who are assigned to that project, and typically, and then I have an employee who knows what project he or she is assigned to. So I have a one-to-many and a many-to-one back. This is pretty normal stuff. Unfortunately, you hand this, again, you try to take some objects that are built like this with the back pointer to JAXB, and it will just stack overflow as it goes round and round recursively forever. So what you can do out of the box JAXB is you can say, well, let's not marshal one of those. Let's just ignore the relationship. So if I want to ignore this back pointer, the project pointer of the employee back to the employees, that way I marshal the project, then the employees, and I'm done. That produces nice XML. You can use XML transient for that. So you can actually put XML transient on the property that you don't want to be marshaled, to be ignored, and that's fine. So you end up with, unfortunately, your objects, employee and project here, have nice bidirectional relationships. You go to XML, you get some flat document, and when you unmarshal that document, you don't get that relationship back. Okay, so you can imagine that if I'm building an application where I send some stuff from my server side down to the client, they make some changes, they ship it back, I unmarshal it, and what they're telling me from a JPA perspective is that this employee is not associated with that project. Right? I've lost information, actually lost information, and in JPA, if you were to try and merge these changes back in, or this unmarshaled document back in, you'll see some delete statements or something happen. So this is not good. We're losing information in this transformation, which we don't want to do. So we've added this XML inverse reference annotation. The hardest part of this was coming up with a good name. Even now, we're not entirely sure it's a great name. But what we're doing here is we're annotating this project reference to say, this is a pointer to my parent. When you're marshaling up project and you get to employee, don't marshal up, don't follow this link, right? Don't recurse down this link. But that's fine. So you end up with project contains a bunch of employees in XML or JSON. But when you unmarshal, as we unmarshal, what we know is that as we unmarshal the employee, we say, oh, we've unmarshaled the project, we're unmarshaling employees. We see the employees have this inverse reference to say, oh, this object has a reference to its containing object, to the project. So we'll reestablish that link. And so we now have a fully bidirectional relationship reestablished. So really it just does this, right? So we don't lose. It's not lossy. We don't lose information. This is not a bad little solution, and it's a minor feature that solves a really big hassle, because what most people do, in my experience, anyway, if I go back to here, what most people do is they take this class, and in order to be able to marshal these JPA objects, they build lightweight sort of DAO type things that they pass to the JAXB marshaller. And then they manually go through when they unmarshal to avoid this problem, and then they will go through and they'll fiddle with the pointers themselves, right? So they'll have to basically take manual control over the complex graph they're reading, build something simple for JAXB, and then stream it out, and then deal with it coming back. My goal is to not do anything. I want my frameworks to do my work for me. I want to read data, and I want to ship it across the wire and get it back and do nothing else. And so with this technology, with this little simple change, I can start to do these things. Okay, so let me give you a demo. I'm going to be very brave and do a bunch of demos. I've got multiple Eclipse is running here. Running here. How's that? That's okay. Okay, so this is actually pretty cool, the way the things that this enables. So I've got a very small example here, and actually in my abstract I promised to build a bigger application. I decided it's much simpler to give you examples of these things, and you'll see how they're put together in the last example, or the second to last example, this sort of comes together. So here's, I have a database with a single class, or sorry, I have customers, addresses, phone numbers. Customers have a collection of phone numbers, and they have an address. So a very simple object model, okay? And I've got a database here. I think it's MySQL. It's got a single customer in it. And what I'm going to do is be able to do stuff like this. Create a persistence unit here. Go and find customer number 1. Then I'm going to create a JAXB context. I'm going to create a marshaller. I'm going to turn the formatting on. I want media type XML, and this actually will be ignored, of course. Then I'm going to export. I'm going to marshal that object that I've got in memory into the file customer.xml. Right? So this looks like the top part is just plain old JPA, and the bottom is plain old JAXB, except for a property here. So if I run this, I think the fonts are big enough, and I just try to zoom this thing up here. Come on. I'm having sensitivity issues here. Let's just zoom. Okay, we'll zoom. Okay, so you saw some selects, right? That's all there is there. Not very exciting. The file itself gets output, and here's the XML, right? So I've got this customer. It's Woody Allen. He lives in New York, Central Park East. I think he's on East. I don't know. And if you look at the objects, though, you'll see that customer here has a set of phone numbers, and the phone numbers have reference up to their owning object, right, which is normal enough. But I've put an XML inverse reference. If I take that off of there, of course, well, I don't need to show you, but I'm going to get an exception because JAXB is going to try and recurse infinitely and then fail. So having this in there lets me marshal it out. What's cool about this sort of technology is I have this document here, and this is where JAXB and JPA kind of fit together nicely, is I can go and change a document, right? So I can call them Tim Allen, right? I have a document now. If I unmarshal, here's me unmarshaling. So I'm going to read the file customer XML back in now, and then I'm going to create an entity manager of the same persistence unit, and I'm going to call merge. So I'm going to take this red object and call it merge, and then JPA will actually do a delta. It'll check on this document I read versus what I've got. Is there any change? And if so, I should apply those changes. So if I run this, try and get this window to resize. Maybe it's not my mouse. I have no idea why this doesn't want to select that resizer. Zoom it up. Okay, so we see selection because, of course, when we're doing a merge, we have to go and read the original objects. But you'll notice there's an update. So JPA figured out that the name had changed. So if, in that entire document, it detected the small change and applied just that change. This is very cool for being able to go back and forth with clients and servers with data and get those changes back in. And the code, again, is very vanilla-looking code. Right? There's nothing very fancy here about JAXB or JPA. Just to show you the JSON side of it, if I go to the marshaller, and I switch the media type to JSON. Oops, try and save that, yep. And run it again. Oops, that's the wrong one. We don't want that one. Run the marshaller. And take a look at customer XML. And now I'm getting JSON out. So really, that's all it took for me to get JSON. So you can see how, for me, I was building web applications. Crash course in JavaScript, it's good times. And I was working with XML originally, and you get XML across a REST API, REST call. You deal with the XML. You basically build yourself some JavaScript objects and put them on the screen. Now with this, I get JSON back. I unmarshal to JavaScript objects, and I just interact with them. My code on the client side went down significantly because I was able to go from XML to JSON. So this actually is pretty handy. Okay, I'm going to stop there for now. Okay. Another JPA. I think I better hurry up because I have lots to talk about. So dynamic JPA is this idea that you could have JPA without Java classes up front. And so there's a number of cases why you might want to do this. If you're very model-driven, if you have a very model-driven sort of application where it's all metadata, You know, you have a model, all the classes you're dealing with are defined in metadata in a database, in XML files, whatever. You may want to spin up persistence for those definitions. You don't necessarily have to code generate to do this. You can, but you don't have to code generate. We can do it on the fly. Another feature we have on these dynamic JPA, or any entities in EclipseLink, is their extensibility. And I get this very commonly with people who build applications that are sort of commercial applications that get installed at a client site, and then the customer configures them. They add extensions. You know, you build an application for insurance, and you want to add on some extra fields because that customer wants to track certain information. And if you haven't coded it into your classes, you're kind of out of luck. So we have features for handling sort of, I guess, deployment time or install time, configuration, or extensibility. So what we've done is we've taken a JPA mapping file. This is a standard JPA mapping file with a couple of extra bits. And so we've added this access type virtual, which tells us as we're reading this mapping file, this is a normal process in JPA is to read these mapping files, and normally you would combine this XML with some Java classes. As we read this XML file, we see the access type is virtual. We know this is not a real class. And so we will initiate the process of basically ASM encoding, generating a class for this, this description. So the access type is virtual, doesn't really exist. And then the other thing I need to know is the attribute type. So in normal JPA, the class has a definition and has a type on it. I don't have a class, so I need to put the type somewhere. So I capture the type here. So I've got, you know, address has city, or address ID is an int, city, country, and postal code are all strings, and we will basically let you generate a class from that. And once you've got that class, it's like any other entity that existed in your system. You can use JPQL queries on it. I know there's one team at Oracle internally who uses this to basically do what I'm saying. They have their model is all metadata. In fact, their customers kind of define a data model that they want to interact, that they want to store in this application, and then they want to query on it, and they don't want to know that it doesn't really exist. As far as they can tell, there's a real model back there, although it's actually all virtual, even though the queries still work. And the other feature is extensibility. So this is something that people have been doing for years. Everyone has done this. You have this problem of I have a class and you have a set of extra stuff you need to capture. Typically people put a map or they somehow deal with this set of properties themselves. It's in your application code, kind of in your face. You have to deal with the persistence. And so all we've done is taken this thing that people do all the time and put it in the framework. So it's built in out of the box. And so the idea is that you've got some class, it'll have a collection of properties. And we do a few more things around them that make them a little bit more interesting. But we do support this basic idea of a map of extra properties. Excuse me. So far, I'm not stopping. I'm not sounding like Darth Vader yet. Eh? So, okay. So what we do is, if you want to have an extensible class, we have an annotation here to tell us that you have these virtual access methods. In other words, for getting and setting of properties, there's some properties on this class that are actually virtual. They don't really exist. By default, we will, if you try to interact with these properties that you define, I'll show you how to do that in a second, then we will call get and set. So we'll just call these two methods here by default. So it's just get, it's just set. I know I had someone who was using Groovy, and this caused a lot of trouble. It turns out that virtual access methods has properties that let you set the name of the get and set method. So we don't really care how you do this inside your object, but you just give us a way to get and set these these arbitrary properties on your class, and we will take care of the rest. We'll map them to. Usually, people map them to extra columns in your object. So they'll create a set of tables with some extra columns and support storage of these additional things in this sort of expansion space on your table. I was going to say something. I forgot what it was. So here's an example of this. So here's a player class. And this comes from a demo we actually have. You can download this demo. I showed it last year as part of the multi-tenancy example called My Sports. And in My Sports, you can actually configure each sports team with extra properties. And this is how we do it. So we capture, for a player on a team, player has a basic definition in our system. But I can say, well, I want to add penalty minutes and the position they play into this application. It's important for me in my particular instance of the application. So I have a simple file here. Again, the access type is virtual, you'll notice. And we map it to certain columns. We, again, specify the type because we don't know. But what's really interesting is that once you've got these virtual properties added onto an entity, you can actually use them in JPQL queries. So you can say, select me all the players whose penalty minutes is greater than 10. And we will actually process that successfully, map it to the right columns, do the right SQL query, and get it back for you. So this is quite a useful feature for customizing at install time. And it's really it's something that people do actually need. Like I say, they often have to build it themselves, but they don't get all the benefits of having it in the framework. They don't get things like the JPQL query support. So it's a pretty cool feature. Oh, and there's the again the types and virtuals. Okay, so I'm going to move past that one on to the last two because time is a bit short. So RESTful JPA. So we saw that I can go from JPA to XML or JSON. And the obvious use case is for REST access. So again, if you're going to go from the back end to the front end, I've got, from the middle tier, I've got JPA going to the database. And on the front end, I've got some kind of web technologies. And right now, of course, is JAX-WS and JAX-RS. And so we focus on JAX-RS. We already have some JAX-WS support in EclipseLink in the DBWS component. So I'm not going to give you the full REST tutorial, but I'll give you the basics. We'll walk through a little example of how I would do some REST and then show you how what we're doing is a bit different. So, of course, this is what case REST is where you can have remote access over HTTP to identified resources. So things that are uniquely identifiable through a URI. And that maps reasonably well in a naive, the naive basic mapping for that is, maybe I could have a URI for every entity. Everything that has a primary key or an ID could have a URI. Right, that's the sort of that's the basic idea, and of course you want to go beyond that. But that's the basic idea we're following here. Is if REST is for accessing and interacting with resources, what if the resources are persistent objects behind the scenes? And so this is, of course, JAX-RS is covered by the standard 331, and then currently they're working on 339 for JAX-RS 2. And let me give you a quick walkthrough. So here's how you do it without our extensions, or without EclipseLink JPA-RS. This is JAX-RS. So I have a bean, service invoice service, and I want to be able to read one. So I want to be able to have someone be able to read an invoice and get it, access to it across the web. I'm going to make that a stateless session bean, and I'm going to inject the entity manager. And I actually have omitted the inject for the entity manager. But I'm going to inject an entity manager for my my invoice persistence unit, or my accounting persistence unit. And so here I am, I'm building, let's say this is server side, right? So ignoring the REST side, I have a bean here that offers service to be able to read a particular invoice. You can see I just pass the parameter into the find, I get an invoice, returns invoice. Now I'm going to make it web enabled. So JAX-RS is great because it's very simple. I put a path annotation on here saying I want to bind this bean to the invoice path. So I have my app, HTTP, my app, my domain, my port / my application / invoice will get me now to this bean. And then I want to bind. I want to set up a get. HTTP get should be routed to the read method. So I put a get on here, and it'll be invoice / some ID. So I have another path extension here with a variable ID. And the value you pass in the URI gets bound to this little property. And then what's cool with JAX-RS is it'll get injected through the path param there as the method parameter. So the URI value gets actually passed into the method. So now someone can type, my URI / invoice / for, and get it. Let me show you here. Oops, there we are. For, and they can actually get an object back across the wire. I put a produces in there because I can control what I want to return, XML or JSON, or text or whatever. So there's a number of different possibilities here. So that's what you have to do if you want to go and take JPA classes and expose them. This is what you have to do, basically. And you have to do this a lot, it turns out. So at the high level, this is what you have, right? Clients talking to the server, a server, JDBC. So we're going to drill down into the server here right now. So with JAX-RS, as it is today, what you have to do, if you have this accounting persistence unit and you want to get at that data, you're going to have to write one of those beans, right? So JAX-RS, and let's say you have an invoice bean. It can get, put, does all the CRUD type of operations. You've written a bunch of methods that bind to HTTP gets and deletes and so on. So you have to write your bean, put all your annotations on, get all the method injection working correctly for parameters, and you're good. So if someone wanted to expose multiple beans, you're going to write a lot of these JAX-RS classes, right, enable classes. or a lot of methods, your choice, right? Probably more beans so you can bind them to different paths. So invoices, contracts, payments, the usual type of thing in HTTP. So if we were to walk through this, you'll get a GET, for example, for invoice 4. So there's some, your application server, etc., /invoice 4. JAX-RS takes that, looks at the URI and says, I understand where invoice goes. Invoice is routed to a certain bean, so it forwards the request to a certain bean. It knows it's a GET, so it knows what method. So we've seen that, right? Goes to the invoice bean. In your invoice bean, you do what you have to do, use JPA, read some data, send it back. Okay, so that's the path that we sort of saw. But again, there's a lot of beans you're going to have to write yourself. So what we've done is we've added another layer in here, right? So JPA-RS is a little layer, sits behind JAX-RS, and in between you and your persistence units. And you can have more than one, of course. There can be many persistence units, which means with standard JAX-RS, you'd have many beans exposing the data in that persistence unit. So I have JPA-RS in between, and it automatically will expose and provide REST APIs for the various beans in your persistence units or entities. So I can interact with any number of these without any code at all. So if someone were to make a call with the prefix, in this case I'm using JPA-RS, but it's arbitrary what we call this URI here. But I'm going to use a JPA-RS call. I want to identify now the persistence unit. So my path is a little bit longer. So I identify the persistence unit, which is going to be accounting, and I want to get a certain invoice in the accounting subsystem. JAX-RS understands, they've bound, you've bound JPA-RS to this certain path, so all requests, the certain root URI will come into JPA-RS. From there, we take it down to the right persistence unit, to the right beans, let you find the object you're working with, or look for it, read it, and pass it back for you. So you don't actually write any code. So all that code you have to write is gone. So you can use REST. You can use REST with JSON or XML. So we saw that we can do the XML or JSON, and that's being leveraged in here. So you can get what you want. When you make an HTTP request and you say the accepted type, you can say XML or JSON. All the usual operations are available to you. The gets, puts, posts, delete, etc. We expose named queries. So if you have some named queries in your domain model, you can invoke them across the wire, which is cool. And in EclipseLink, we have clustered caching support. So as you're reading data into the middle tier in a clustered environment, you get to leverage that so your reads can get more efficient. We're doing the work around clustering. The dynamic persistence is available too. So it's actually possible to build a REST service with no classes whatsoever. And we have a little sort of demo we've been working on where you can pick out a few tables, and we basically reverse engineer what the classes would look like, and then spin up REST services, and suddenly you've got a data service from nothing, right? Just point to some tables. It works as simple as that. No code required, and it's pretty slick. I should say that a lot of this work is coming out of Avatar. Have you heard Avatar? It was announced last year at Java 1, and it's really an initiative to come up with a better way of programming with REST and HTML5, not REST, but HTML5 and Java, right? How do these things fit together? And so the work we're doing here was really driven by, this is the part that we understand, right? If we're going to build HTML5 applications and we're the database guys, this is the stuff that we know how to do. So we're sort of building this as a contribution to sort of this overall, I'd say fairly ill-defined or not well-defined initiative called Avatar. And so there was a bit of talk about this at Java 1 this year. Again, and I think you'll see quite a bit more by next year. But at this point, this work has been done coming out of that initiative. So this is sort of the fruits of our labor. We're a bit ahead of the game, though, because we had so many pieces already in place that we could leverage that we got quite a bit done already. So let me give you a little demo. Okay, a different instance. Okay, a different instance of Eclipse running. That's right. Okay. Excuse me. So I've got an object model here that's based on an open source or a freely available database of comic books. I collect comic books, so this is great news to have open source sort of data for those comics. So it has things like all the publishers around the world, there's tons of them, all the things they publish, all the titles, all the issues, who drew them. I mean, it has a lot of data, right? And it's also crowdsourced. So you can download this data. I did that, and then I reverse engineered some classes out of that, and then I put some named queries on and so on. So I've got things like publishers. So here's a publisher object, and you see I've written a couple of named queries here. So publisher all, select me all the publishers, all of them, or collected, all the ones that a bit more complicated query with a parameter. No, actually, sorry, it's not parameter, it's sorted. And I can invoke these across the web. So what I've done is I've got a project here in Eclipse that just contains the domain model. So it's got domain model, it's got the classes, they have JPA annotations on them, some JAXB annotations on them, but that's what I have. And then I've got a web application, which is called JAX-RS here, and it actually doesn't have, it just has, if I go down here, it has a jar added to it. So the way we enable JPA-RS is with a web fragment. So currently, if you have, let's say, Glassfish, or which is currently the easiest thing to do, or even WebLogic that happen to have EclipseLink already installed, if you just drag and drop the JPA-RS web fragment into your web-inf-lib, then this will enable JPA-RS services. So basically, we're hooking into, in this case, Jersey. Jersey will be used to provide the service, but because we're a web fragment, we sort of get some control to sort of initialize ourselves and get hooked in. So that works quite nicely. So that's all we have in here is I have that, and I have some web pages. So I've got some JavaScript. I got a web page, and yeah, a bunch of JavaScript behind the scenes in Dojo. And I was smart enough to install Dojo locally, so I didn't have to depend on the wireless, which is a good plan. You never know, right? So this is deployed and running on Glassfish, and I can show you here Glassfish servers. So you can see what's deployed. So I've got the domain model classes and that JPA-RS jar are deployed as part of the JAX-RS app. And then I have a separate web application. So the web application is just JavaScript and HTML, right? So a lot of JavaScript I've written here and HTML, and that's all there is. So I have two applications. One's the client, one's the sort of the server. So if I go over here, this demo, and I'm using Chrome, and I've brought up the development tools. What's nice is you can sit and monitor the network, so it's good to see what's going back and forth. So if you see here, I brought this application, I got a list of publishers here. If you look, you'll see there was a call made for publisher collected, and here's the URI. Now, it's not that big for you, perhaps, in the back. Localhost, JAX-RS persistence, comics query, publisher.collected. So we actually invoked this query over here, over REST, and what I got back was a bunch of JSON in this case, which was all rendered into this select list here. So as I click through, click one, go to my network here. You can see I've invoked another REST API here, another query, collected series for publisher, which, why can I not scroll over there? I can't see that. You'll notice it has a parameter, semicolon pub ID equals. So in that case, if I go over to collected series, you'll see I have a named query over there that takes a parameter, right? So it's got an input parameter, and we're able to take the parameter from the URI and actually bind it to the parameter that's required for the query and inject it into the query and then run the query. So it's all hooked up together. And again, I haven't actually written any code for this. So what's nice about this is I can take my domain model, and then it left me to focus on learning JavaScript. And you can tell I haven't gotten very far because it's not that sexy. Usually my demos I get, as you saw before, console output. That's as good as it gets, right? If you're a server-side guy. So having even a UI of any kind is kind of exciting. Okay. So that you can download that today, and that's shipping since EclipseLink 2.4, although there's some big improvements coming in 2.4.2, which is relatively soon. The big thing that we do in JPA-RS that's subtle, the number of subtle things that came out was, again, you have a complex graph of objects. How do you break that graph of objects up and ship it across the wire? So we're basically using links. We're creating the links for references between objects, and actually when you get down to the client, what you get back is objects with links to their associated resources and so on, what you'd expect in a REST API. So there's a lot of tweaking going on in that space right now to make this a little bit more efficient The first version of JPA-RS that's shipping, the 2.4.0, was not as great with the links. I think there's a big improvement in the links area, because I really would like, I'm really waiting for these things to come out, because it offers a lot more functionality around manipulating lists remotely and that kind of thing, like who's in my collection. It's really hard to do across REST. So we have API coming for that. Okay, I think we're on schedule. So the last thing I want to talk about is NoSQL support. So, NoSQL is big, right? Everyone's talking about them. Everyone's, thinking they might want to use one day, or they download them. For people like ourselves on the EclipseLink team, it's really a problem because they're just so non-standard. Right? There's no standards. So it's easy to build a persistence layer on top of standards like JDBC or JCA adapters, for example, which we do. That's great. These databases don't have a common definition. So they're columnar, graph, document databases, so different kinds of internal structures, different feature sets. Some have query languages, some don't. And if you go, if you learn a product, you're going to learn that product, and it's going to cost you. Then you go to the next product, you have to learn its API. So there's a fair bit of overhead for switching. So it's a bit of a challenge. Excuse me. So our goal is to provide JPA-style access to NoSQL databases. So we'd like to be able to just spin up a persistence unit, query some objects, get them back, play with them, put them back. Now it turns out that I mentioned early in the talk, I mentioned our mainframe connectivity. So that led to JCA connectivity, to non-relational data sources. So we actually had support in EclipseLink for some years to non-relational data sources, and we called it EIS, or Enterprise Information Systems Connectivity. And I'd stopped talking about it at conferences because no one really used it, really. I couldn't do a show of hands, no one's ever heard of it, no one uses it. But turns out that these NoSQL databases are just like these things. They're non-relational data sources, right? So we've leveraged a bunch of infrastructure we already had that was kind of lying fallow within EclipseLink, and applied it to the NoSQL databases, and it turns out to be a really good fit. So we're kind of rethinking, like we don't say EIS anymore, now it's just NoSQL, right? I mean, it's kind of like, it's a modern thing. Just rebrand what you have and call it the new thing, and it's new. But it actually works out to be the case. What we had to do is we've introduced a couple of annotations, so we need to know which of, what entities are relational, which ones are non-relational. So we have a NoSQL annotation for non-relational entities. And our approach is very straightforward. We're not trying to layer on top of NoSQL databases some kind of abstraction that makes you think it's relational. Okay, we know if you've bought MongoDB, then you've bought MongoDB, and you should be able to get at the features in MongoDB, and we're not going to try and tell you, no, we're going to make it look relational to you, because it's not relational, right? So our goal is to leverage what's in the platform. So if a database has certain kinds of features, we're going to let you get at them. We're not going to layer on some other functionality that makes it somehow other than what it is that you bought. And so, I mean, I bring this up because it's kind of a contrast with Hibernate OGM. So the OGM, they're trying to provide queryability and joins and all kinds of things on top of currently InfiniSpan, and they've realized that they could maybe think about NoSQL databases also, but their motivation is a little bit different. So it's a perfectly valid approach. That's not our approach. Our approach is JPA access to non-relational databases and get at what's in there. And the reason this is important is if you're in an environment where, well, if you're like an Oracle, right? So we're buying a company every 5 minutes, it seems. So you buy a company, and they've got a database, MongoDB database. I'm saying Mongo because we have some support for Mongo. They've got a MongoDB database full of really cool data. And you've got this enterprise system you're building already, and you're like, I could really use some of that data. Well, I don't want you to have to reformat the data in the database. I want you to be able to go to that database and just access it. If I'm going to impose structure on how your data is stored in that database, no one's going to go for that. So my goal is to let you access what's there, not tell you how to store entities in some proprietary format in that NoSQL database. We want to go with what's available. So very open and transparent sort of communication between the JPA world and that NoSQL world. So in this first release, we have ship support for MongoDB and Oracle NoSQL. MongoDB because actually we had a partner in the Eclipse community who wanted MongoDB support first. So if people in open source want to help, then that's what we do. It's cool. And Oracle NoSQL because I work for Oracle. Makes sense. And so I'll talk about Polyglot in a second here. So some things make sense in NoSQL world and some things don't. So obviously objects that are persistent make sense. Embeddable objects, very common in NoSQL databases. Element collections, one-to-ones, so relationships all make sense. Querying can work in some cases if the database has queryability, a query framework. Some of them don't. They're just pure key value stores, and so there's no query possible. So we can't help you there. And obviously relational things, especially physical mappings, don't make much sense, right? So, table-related stuff, table generators, column names, that doesn't make any sense. Sorry. On the querying side, there's two kinds of queries. There's JPQL queries, nice, portable JPQL. Then there's native queries. And what we're doing is we're actually translating, when possible, JPQL queries to the target database's query framework and executing them. And we're also letting you pass native queries right through. So if your database you're targeting has its own query language and you can only write the query using their framework, we'll let you go ahead and do that and pass it through. And they can, of course, be statically defined with named queries, or you can do them on the fly with dynamic queries. It's all the same. So here's a little sample of a Mongo mapped class. What's different about this from a standard JPA class is it has this NoSQL annotation on it, and there's a format type, right? So we're saying map. So Mongo has like a mapped-like structure, right? It's a document database with key values on the properties. And they use what do they call it? Binary JSON, or just JSON format, right? So you see documents from Mongo, and we'll see that in a second. They look like JSON, so they have keys and values inside the objects, and so it's mapped structure, as compared to columnar ones, which are indexed. So it's like, which column index are you in? Or even databases that store XML documents, right? Which is the case for some of these EIS type older systems. They use XML. So we have to know what type it is, and we've added field. So field is really an alias for column, except that column has a lot of stuff on it that doesn't make any sense. So, the data types don't make any sense. There's a number of things on column, the standard JPA annotation. So we didn't want to be just ignoring stuff. We said, okay, we'll come up with field, which better describes the mapping. Although my colleague Gunnar, who's the Eclipse guy I work with from the community, he's pretty savvy, and he's figured out that he can use @column anyway and just put name, and it works. It's the same. So that if he's moving between relational and non-relational, he can just keep the same mappings. It minimizes the churn. But this is what we do here. Generated values work fine. So in this case, we're going to use Mongo's UUID generation. Other than that, it looks the same, right? This class is pretty vanilla JPA. Here's some JPQL. Stuff works. Selecting where values greater than this, or joining embedded objects where something has some properties greater than some value. And here's some native queries at the bottom. Those are perfectly valid. And you'll see how we pass them. Create named native query. And it's just a string. So on relational, that string is SQL. And EclipseLink, we don't really care what's in there, right? So we just take this string, pass it to JDBC driver, it executes it, gives us back results. In this case, the query string happens to be Mongo's query language. We pass it on to Mongo. It runs the query, gives us back results. So the world is all good. So it looks pretty straightforward. So let me show you what it looks like. So what I'm going to do is, okay, now which of these various ones do I want to use? Okay, so what I'm going to do is first show you, since I've just got enough time, it's perfect. I've got a sample of, I have an application here with one class because it just for simplicity. Single class, this is mapped to MySQL, okay? So I have a class here, customer, it's in MySQL, here's my persistence XML, right? So the connection is set to, it's Derby, it's embedded Derby, so it's going to Derby. You can tell I'm all over the place. I'm very open about which database, I'm not partial. And a simple example here, so I'm going to, what am I going to do here? I'm going to create a customer, and persist it. Then I'm going to remember its ID, close it all up, use the standard JPA2 cache API to evict the cache. EclipseLink has caching. It's very pro-cache. So if I don't evict the caches, I will just find things in cache without any database activity. I want to show you activity. So I'm going to clear the caches. Then I'm going to query the database. I'm going to issue a JPQL query, select customer where the customer ID is equal to the parameter cust ID that I've remembered. Simple as that. So I run that. This is running against Derby. I believe it's initialized. Maybe I have to actually, oh, I think it's all set. Okay, so why in the world does this not want to get bigger? I do not know. Okay, so here you saw it. It's just normal stuff, right? Sequence update, select the name, select from the sequence, insert into the customer. You see my query to get it back, and here I print out the result. So now I want to put this in Mongo instead, say. So what I have to do, is go to my domain object. I'm going to uncomment this annotation that I put in here earlier. So now it's going to be mapped. This is written by James Sutherland, by the way. So James actually has this, a much bigger, this is a subset of a demo he has, but if you Google up EclipseLink and Mongo or EclipseLink NoSQL, you'll find James's blog, and he's the principal developer, where he has a larger example of NoSQL usage with Mongo. Okay, I'm going to put the field here. And sorry. Normal JPA defaulting applies, but Mongo likes _ID for the ID. So we're going to use that. I do that, and then I change the persistence XML a little bit. So the JDBC login info makes no sense because I don't have JDBC. So here's all the JDBC, right? So it's Mongo, or sorry, it's Derby embedded. I'm going to comment that out. I'm going to uncomment the completely non-standard but necessary Mongo connectivity information. Right? So target database is Mongo. Let's just zoom it up a bit. It's like I have delay built in here to this zoomer. You see we have some special properties here, right? So Mongo port, host, database, connection spec, basically stuff we have to do for this NoSQL database to get connected. So having changed the connection and having associated the class with the NoSQL connection, I can run the same application. It will run as before, but a little bit different if I can zoom this up. Okay, so what you see now is populating database. You're seeing a Mongo insert operation taking place, and we're inserting the record here. And then querying it back, you're seeing a find operation on Mongo, and I'm getting it back, and then I'm finding the same result. So that was what it took, right, to switch between the two. Fairly minor change. So that's the tip of the iceberg. Like I say, if you go Google that up, go look for James's blog, you'll find him showing relationships between objects, how we break relationships, store the IDs, and be able to reassemble, lazy load whole structures out of a NoSQL database, for example. And your application is pretty ignorant of what's happening. Point here, which is this concept of polyglot persistence. So Martin Fowler didn't coin this term, but he certainly promoted it quite a bit. And what he's saying is, kind of in the scenario I was describing before, in any enterprise environment, you're going to have more than one database technology. And they have to coexist, and you're going to want to get at all of them at the same time, right? So you got all this cool media stuff in this Mongo database. You've got your accounting information in this other one. So you want to put it all together. How do you do that? Well, we've heard a lot about polyglot languages and programming, but now we're talking about polyglot persistence, the ability to use multiple different database technologies in a single application as transparently as possible. So let me just flip over to a demo. So what I've done here is I've taken this actually the example that James had written, and I partitioned some of the class into Mongo and some of the classes in MySQL. So I've got a Mongo persistence unit. It's got part of the model. So address, customer, order line. And order line has a product. Now, product actually isn't in that model, right? Mongo will not store product. Product is going to be stored in MySQL, in my relational persistence unit. It's over here. And so what I do is, the way I do this in EclipseLink is I have this concept of composite persistence units. It turns out this existed prior to the polyglot. It was mostly used for multiple different relational technologies. So, I'm mixing relational DB2 with Oracle, and I have data that spans those technologies. Now we're spanning not just relational, but NoSQL and relational. So I got a couple of classes in there, and if you look at the persistence unit info for the relational, it has a connection. Actually, this is embedded Derby. I can't get it straight. So this is embedded Derby. those classes, discount and product, go in here. And back over to my Mongo persistence unit, these classes here are going to be stored, and again, using that connection information, right? So we've got that in Mongo-specific connectivity settings here. Those classes are there, but there's relationships between these classes. So you saw that the order line actually has a reference to product. So by putting them all together, I have a composite persistence unit. This is a extension to JPA that we find very useful. So we have a composite PU called that. It contains a couple of jars, the various pieces. I've actually got a flag in here saying it's a composite persistence unit, but it's actually not necessary. And what's going to happen is all the classes are basically going to merge, in a sense, right? We're going to take all the classes from the various components, and they'll become one product, one persistence unit, except we'll have associated the different classes with different data sources. So as you read and write these objects, they will come into and out of the different data stores. And I can move between them, and well, let me show you the example. I'm just going to create some data here. I'm just going to run this thing, and I'm getting the flash. Time is up. All I'm going to do is create some products. These are relational. Create some customers, non-relational, orders, order lines, and order lines are going to take references to the relational objects. And then I'm going to commit them. Then I'm going to read them back. But let me just run this thing because we're out of time. And it's kind of interesting to watch it's kind of weird to watch this go, but you're seeing all kinds of interactions here. So as we're persisting things, you're seeing inserts into relational database, you're seeing inserts into Mongo, and if you look really closely, and actually I think I can do it over here if I bring in the little utility here I have. You'll see here, this is the actual document in Mongo we've inserted. So you'll see here orders have order lines, and order lines have product IDs. So 51 is that product. So I've got foreign keys in Mongo that refer to the primary keys in the relational database. And I can go back and forth between these structures. And I can put them in, I can pull them back out, I can lazy load across technologies. All of it's perfectly transparent to your application. All right, well, that's very good timing. So I'm not going to give you the story, the roadmap, but basically we're focusing mostly on JPA 2.1 and improving these features here. Part of this is pushing the technology. So JPA 2.1 is closing down. These aren't going to go in there today, but certainly as you're seeing in the Java EE world, we're focused more on HTML5 and REST APIs. So this is technology we really feel is useful for building these applications. So the one message I want to leave you with is really that at EclipseLink we're doing a lot of really cool stuff, pushing the boundaries, and we think there's a lot of really interesting innovation going on there. So when you think of EclipseLink, it's not just relational database, right? That's not what it's all about anymore. It's about data, right? Data services. So I'm out of time. Any questions? I think there's a mic if I can't hear you. Is there a mic? There's a mic. Or you can shout. Overwhelmed? Oh, there you are. Yes, sorry. Go ahead. Can you shout? I'll repeat.
All the cool features you've shown us of EclipseLink with JPA-RS,
Yeah.
NoSQL support,
Yep.
are they foreseen to be in Java EE7?
So the question is, are these features going to EE7? So no. So really, EE7 is closing down, right? They're trying to get that out the door for next spring. At this point, it's too soon. This is new stuff. And the specs are better to consolidate on things that are proven to work and not put stuff in that may work. That's why we did the work on multi-tenancy last year. Let's try it out, get some experience, and then let's talk about standards. So this is really, trying things out. Anything else? Okay. Yes? Okay. So the question really is about sort of queries that span databases. Yeah. So I can't do much for you there, right? I can't take a query and decompose it and run some piece against here, some piece against there. We're just not going to be able to do that. Yeah. The order of execution. The order. So the order that we're inserting data is into satisfy referential integrity rules. So we have to do them in a certain order, right? So something has to exist before I can refer it to insert the thing that refers to it. So that's why you're seeing interleaving of Mongo and Derby. Transaction management is a whole ball of wax. Okay, so I thought someone would bring it up. So Mongo is not transactional, right? So this is really a problem. And it means that I'm going to have to write code to handle when Mongo fails. So it's actually, from the polyglot persistence perspective, that's a real challenge because I've got a relational transactional system and a non-transactional system. Currently, it's kind of roll your own. I'm thinking of the ways out of it, but there's no magic bullet. Yeah. Oh, yeah. One more. Right. So the question is, can I control what gets exposed? That is coming. Yeah. So there will be a config file to let you basically control it. So currently we're exposing everything. That was our sort of get out the door first attempt. We realized that's crazy. There's going to be a config file to let you control what gets exposed, which queries get exposed, all the usual stuff, right? And of course, you obviously should be using security also, right, on top of that. Oh, yes?
What is your opinion on performance of using JPA and JAXB bidirectional relations versus with your just a single section? In your example, you had a project in Amsterdam 40.
Yep. So. I know you're going. So you're concerned about the performance of having the bidirectional relationships. That's normal JPA. So there's nothing non-performant about that. That's normal. The database, you can given a relational in the database, you can map that into Java or not, right? You have a choice whether you want it bidirectional, unidirectional. That's all fine. But our concern was if you do have it bidirectional, then it better not blow up, right? That was really the goal there. You could structure that as a unidirectional relationship, but most people don't. So, okay, I think we're shutting down.
I have
okay.
a question.
Oh, good. Go ahead.
Just
One more.
about the inverse reference.
Inverse reference.
Yeah. Isn't XML ID and ID refs not another workable solution?
I'm sorry?
XML ID and ID refs are also workable solutions.
They don't cover it though. They don't handle, the inverse reference handles a different problem. So yeah, you can use refs, but JAXB is greedy. It will recurse the tree. So if you have a tree that goes around, you can't get at. You can't.
It does. It stops.
Sorry.
It stops circular references.
The problem is it's not, as you saw there. I didn't have to do anything, right? So I'm trying to get away with the minimal amount of interference in my domain model here. So there's more than one way to skin these things. That's true. But all the ID refs and all that kind of stuff is really not what we're going for. If you look at the XML we're producing there, it's a simple hierarchical non-ID ref solution that goes from cyclic to hierarchical and then back again. The solution you're talking about is valid too, but it's way more work. And you'll get a different XML document out also, right? It affects the structure quite a bit. So you're right. There's never only one way. I agree. Yeah. Okay, we better go. Okay, thanks very much.